Okay. So this is the open area model for division, and this is how I'm teaching the kids in class. So the first thing, when I have 540 divided by 5, what this means is this whole area inside is worth 540. So this is the opposite of when I taught the kids the open area model for multiplication, so that they can see the connection. And the one thing about this is it helps with the kids not getting confused on where to put the digits if they're doing long division. Sometimes they put the digits in the wrong place. And also, they don't have to worry about lining things up. And it also teaches the kids about number sense, which is what our ultimate goal is for them to understand with this objective with the Common Core standards. So I tell the kids to identify the basic fact first. So over here they make something called a menu. So 5 times 1 equals 5. Okay? But then, since they're in the hundreds, and the kids learn this about patterns of zeros, how you just do the basic fact, but then just add the number of zeros. So this is 500. That equals 500. So they're going to do 100 times. And 100 times 5 is 500. What does that mean? That means that this whole thing is 540. However, this area that I'm chunking it into is only worth 500. That means that I subtract and have 40 left. And that means that of the 540, 500 is here and 40 is left there. 5 and 40 are our basic facts. And we think about our 5s, and we know that 5 times 8 is 40. So 8 times 5 is 40. Subtract, and they have nothing left. 100 plus 8 is 108. This also helps the kids understand expanded notation, which is something that we had been working on throughout the year too with place value. Okay? So this has a 0 in the quotient, but here, by doing it this way, the kids don't have to worry about forgetting to add a 0 because of using this way. Okay, on to another example. We did this in class today where there was a total of $246, and somebody was going to make payments of 6 payments, and the question was how much was each payment going to be. Again, I have my open area model. Everything inside of here is worth $246. I look for my basic fact of 6 and 24. And then the kids think about, they identify the basic fact, and like 6 times 4 is 24. But since we are going to the tens place here, we do 10 times this, which basically it's 24, but they're adding a 0 for 240. So they're going to go 40 times, which gets them 240. Again, I'm playing off the first lesson I taught them with patterns of 0. Subtract, they get 6. So that means that this area is worth 240. That is worth 6 because 240 plus 6, of course, is 246, which is the entire rectangle. And then what times 6 equals 6, of course, is 1. And, of course, the answer is 41, but in this case it was money, so it's $41. Okay, now I'm going to do one more example. This example has to deal with a remainder. And this is a perfect example because the first two it worked out perfectly as far as the basic fact. This one doesn't, which I like, so I like this example. So let's say we have 175 divided by 7. So this entire open area is 175. What I'm going to do is I'm going to divide it up. So we look at 7 and 17 as our basic facts. So then I have the kids think about the 7s. They don't need to sit here and list every single fact in the 7s. They can look at a chart. They need to know what times 7 gets me close to 17 without going over. So that would be 2. So that's 14. Well, since we're in the hundreds, if 7 times 2 is 14, 7 times 20 would be 140. So therefore, we're going to go 20 times 7 for 140. Subtract and they get 35 left. This 35 goes right here. Okay? So, because again, this area is worth 140, plus the 35 left would be a total of 175. So then, what times 7 equals 35? They don't have to write this. This is just to get them going with the basic fact and how much to chunk it out. So we know it's 5, and you get 35, subtract, and you get 0. So this one's 25. This example was that where this wasn't like, you know, an exact multiple of 7. I thought that one had a remainder. Let me give you one more problem. This one has a remainder.